Hello everyone, welcome to the Learning Notebook. Today we are continuing our series Computer Fundamentals, and this is Lesson 2. In this lesson, we will learn about the Central Processing Unit, or the CPU, understand what a CPU is, why it is important, and how does it help function the personal computer. Whether you are a complete beginner, preparing for competitive examinations, studying for university courses, or simply curious about computers, this series will help you build a strong foundation step by step. But before we begin, make sure to watch Lesson 1, Introduction to PC. Now let's get started. All right, here is our game plan for today. We're going to cover 5 main topics. First, we'll talk about the computer brain. Then we'll break down the manager and worker components. Third, we'll dive into the fetch, decode, execute cycle, followed by the CPU's importance and features. And finally, we'll wrap the whole thing up with a quick recap pop quiz. Section 1, the computer brain, meaning of CPU. To truly understand a computer, you absolutely have to start right at the center of it all. People are always calling the CPU the brain of the computer, right? Well, that's not just some catchy phrase. It's actually incredibly accurate. By definition, the Central Processing Unit, or CPU for short, is a highly complex electronic circuit. And its main job? It processes the data and instructions that are stored inside your computer's memory. Think about it just like your own brain. Your brain gets signals from your eyes or ears, and then it decides what to do. Well, the CPU receives data, performs all the necessary arithmetic, logical, and control operations, and literally makes the whole system run. And it does this nonstop by following a very specific cycle, which we are absolutely going to get into in just a bit. Section 2, Manager and Worker Components, exploring the CU and ALU. What's actually kind of mind-blowing about the CPU is that it isn't just one giant blob doing all the heavy lifting at once. It's basically divided into 2 major specialized units that work together. I like to think of it like a super efficient office. You've got a manager and you've got a worker. Let's meet our manager first. This is the control unit, or the CU. Now, the control unit manages and controls all the operations of the computer system. But here's the catch. It doesn't actually do the math itself. Instead, it's directing the flow of data between the CPU, the memory, and your input and output devices. It fetches instructions, decodes them so the system actually understands what needs to be done, and perfectly controls the timing and execution of everything. So as an example, when you press a key on your keyboard, it's the control unit that makes sure that specific signal goes precisely to the memory and then routes correctly to the processor. It's the ultimate coordinator. Okay, so if the CU is the manager, let's meet our worker. This is the Arithmetic Logic Unit, or ALU. While the manager is busy organizing everything, the ALU is rolling up its sleeves and doing the actual processing. It handles all the mathematical operations. We're talking addition, subtraction, multiplication, division, the whole shebang. But it doesn't stop there. It also executes logical comparisons, so figuring out if one number is greater than, less than, or equal to another, using logic gates like and, or, and not. Literally all the decision-making and calculations or programs need happen right here. If you type 10 plus 5 into a calculator app, it's the ALU that is actually crunching those numbers to spit out 15. Seeing them side by side really helps illustrate the dynamic between the two. The CU controls operations, right? But the ALU performs the calculations. The CU handles the coordination, while the ALU handles the raw processing. The CU is in charge of controlling data flow, whereas the ALU tackles the arithmetic and logic. Basically, the CU plays the role of the manager, so it produces no direct output itself. But the ALU is the worker, actually producing the final results. They're just a perfect team. Section 3, Fetch, Decode, Execute Cycle, the working of a CPU. So how exactly does this manager and worker team operate on a millisecond to millisecond basis? Well, they follow a very strict continuous routine. This is exactly how a single instruction gets processed. Step 1 is the fetch. The control unit reaches out to the computer's memory and grabs the next instruction. Step 2 is decode. The control unit interprets that instruction to figure out exactly what needs to be done. Step 3 is execute. The manager hands it off to our worker, the arithmetic logic unit, and the ALU actually performs that mathematical or logical operation. And finally, step 4 is store or output. The final result is either saved back into the memory or it's displayed right there on your screen. Fetch, decode, execute, store. Your CPU is running through this cycle millions, sometimes even billions of times every single second. No way, right? It's incredibly fast. Section 4, CPU importance and features. Why it all matters. Now that we've zoomed way in to see that microscopic step-by-step cycle, let's zoom back out for a second. Why does all of this matter so much to your personal computer? Well, the most absolutely crucial point is that without the CPU, your computer just cannot function. Its importance really can't be overstated. It literally executes all computer instructions. It's the central hub that coordinates all your hardware components so they play nicely together. By performing all those calculations and logic decisions, it guarantees the smooth, seamless functioning of the entire system. And honestly, because it can process that fetch, decode, execute cycle so insanely fast, it's the very thing that enables multitasking. That's what lets you listen to music, browse the web, and type a document all at the exact same time. To pull all of that off, the CPU relies on a few really key features. First, obviously, it has an incredibly fast processing speed. Second, it works continuously using internal clock signals to keep everything perfectly synchronized. Every little tick of that clock is an instruction being processed. Third, as we saw with the ALU, it is super versatile, handling both logical and arithmetic tasks. And finally, it serves as the ultimate central unit, maintaining absolute control over the entire computer system. Section 5. Quick recap pop quiz. Test your knowledge. All right, class, it is time to put everything we just learned to the test. I want you to actively think of the answer before I reveal it. Question 1. CPU stands for: is it A, Central Processing Unit, B, Central Programming Unit, C, Computer Processing Unit, or D, Control Processing Unit? Think about it. And yep, the correct answer is A, Central Processing Unit. Great start. Let's move on to question 2. The CPU is considered the A, Memory Unit, B, Input Device, C, Brain of the computer, or D, Storage Device. Now, we talked about this right at the beginning of the lesson. It is, of course, C, the brain of the computer. Moving right along to question 3, let's see if you remember our manager and worker. The CPU mainly consists of: is it A, RAM and ROM, B, ALU and CU, C, monitor and keyboard, or D, hard disk and printer? Got your answer? The correct one is B, the arithmetic logic unit and the control unit. Question 4. Speaking of the ALU, what does ALU actually stand for? Is it A, arithmetic logic unit, B, automatic logical unit, C, arithmetic local unit, or D, active logic unit? Our hardworking number cruncher is A, the arithmetic logic unit. And finally, our last question. Question 5. CU stands for A, central utility, B, control unit, C, computer unit, or D, core unit. Our ultimate manager of operations is B, the control unit. Excellent job, everyone. If you got those right, you have a really solid understanding of the CPU. Next time you open up a video game or stream a movie, take a second to ask yourself, how many billions of calculations is your CPU's manager and worker executing right at this very moment just to make that happen? It's pretty wild to think about. So that was it for today's lesson. I hope you found this class useful and learned something new about personal computers. Don't forget to like, share, and subscribe for upcoming lessons in our Computer Fundamentals series. If you'd like printable PDF notes for each lesson, let me know in the comments section. In the next class, we will study types of main memory. Until then, stay tuned, stay healthy, and happy studying. Thank you for watching, and I'll see you in the next lesson.